Good morning, children. My name is B. Ravinder Reddy. We are discussing 11th standard states of matter. What we are discussing? States of matter. In this states of matter, we are completed lecture number 1, lecture number 2, lecture number 3. We are at lecture number 4. In this lecture number 4, what we are going to discuss? Gas laws. What we are going to discuss? Gas laws. What is mean by gas law? What is meant by gas law? So gas laws means the laws which can explain what relation among measurable properties of gases. The laws which can explain what relation among measurable properties of gases or established relations among measurable properties of gases are called as gas laws. What are the measurable properties we have? MTV is equal to PD. Music television is equal to public demand. Mass, temperature, volume, pressure and density. These are the measurable properties of gases. So in these measurable properties of gases, so instead of mass we generally considered as number of moles. Then how many gas laws we have? So we have total 6 gas laws, but in these 6 gas laws, first let we discuss about 4 gas laws. Under these 4 gas laws, first one is Boyle's law. First one is Boyle's law. Second one is Charles law. And third one is Geluzak law. And fourth one is Avogadro's law. Fourth one is Avogadro's law. Now whatever it may be the gas law we are considered, every gas law should explain relation among measurable properties of gases. Gas laws can explain relation among measurable properties of gases. NTVP. Why did I didn't wrote density? Density is not measurable property of the gas, but we wrote density in order to easy remembering of this principle. Now Boyle's law explains relation among which measurable properties. This is volume and pressure. Remaining to are constants. So what is the relation? V is inversely proportional to pressure. If volume is increases, pressure is decreases as these two constants. Next, Charles law explains relation among temperature and volume. So that's why the remaining two properties or two characteristics are constants. Geluzak law explains relation among T and P, temperature and pressure. So these two are constants. What is the relation of Geluzak law? Temperature is proportional to pressure under these two constants. If these two are constants, temperature is proportional to volume. Next one, Avogadro's law. In this Avogadro's law, what will happen? This is the V is proportional to N. At these it will gives relation in between these two. These two are constants. Next one here in this Avogadro's law we have two different statements. First statement is V is proportional to N, and second statement is P is proportional to N. That means it will give relation among these two properties. Remaining two are constants. Here is P is proportional to N. So these are the about the gas laws, different gas laws. Now we can now we will explain, or now we will enter into so Boyle's law. So this Boyle's law what will explain, and what is the relations are there, what are the mathematical principles are there, how it is useful in our daily life. Now let we discuss. Boyle's law. Boyle's law explains relation among volume and pressure. Boyle's law explains relation among volume and pressure. So remaining two are constants. So how we will define? At constant temperature, the volume of given mass of gas. At constant temperature, the volume of given mass of gas is inversely proportional to pressure. At constant temperature, the volume of given mass of gas is inversely proportional to pressure. These two are constants. Inversely proportional to pressure. When we wrote inversely proportional, we should write 1 by P. So V is proportional to 1 by P. We read as V is inversely proportional to pressure. So now this is the what mathematical relation. So now in order to remove the proportionality symbol, what we will do, we put what is equal to and a constant k into 1 by p. We can write what k into 1 is k by p. So now p sent to this side, what will happen, sir? Vp is equal to k. Vp is equal to k. So now I am writing what a principle from here. Whenever inverse relation is there, v1 by v2 is equal to, in p's we should write, so p2 by p1. So whenever inverse relation is present, where we will get 1, so here we should get what, 2. If it is 2, here we should get what, 1. So this is the what inverse relation, that is principle we wrote from inverse relation. So here what, how we can write, so here constant is there, so that's why v1 p1 is equal to v2 p2, or p1 v1 is equal to p2 v2. So these are the what other principles. So now pv is equal to constant we have. From this pv is equal to constant, how we can define this gas law? So from this what pv is equal to constant, from this pv is equal to constant we can define as, at constant temperature, the product of volume and pressure, the product of volume and pressure, or the product of pressure and volume, at constant temperature, the product of water pressure and volume of given mass of gas is always constant, So this is also called as what, Boyle's law. Boyle's law is what, at constant temperature, the product of pressure and volume of given mass of gas is constant, So this is the what concept related to what about the Boyle's law. So in Boyle's law what we have, so V is equal to K by P we have, or I am taking P this side and V this side. So that's why P is equal to, we can write what, K by what V we can write, K by V we can write. So this is at what, constant mass and constant temperature, or constant number of moles and constant temperature. So now, so what we have, what D is equal to M by V, mass by volume. So the volume, the mass of what, a unit volume of the substance is said to be what, density. So mass by volume. If mass is constant, if we remove constant and is equal to, we can put what, so proportionality symbol. So that's why 1 by V is proportional to what, D. So that's why this I am writing as K is equal, P is equal to K into 1 by V I am writing. So that's why I am writing as what, P is equal to K into 1 by V. In the place of 1 by V I am writing what, D. So if I remove again is equal to and constant, we can put what, again proportionality symbol. Again what, proportionality symbol. This is at what, constant mass and what, temperature, or constant number of moles or temperature. So this is also what, Boyle's law. This is what, third form of Boyle's law. What is the second form of Boyle's law? Second form of Boyle's law is what, PV is equal to constant. This is the what, second form. What is the first form of Boyle's law? V is proportional to 1 by P. This is the what, first form of what, Boyle's law. V is proportional to 1 by P, first form. PV is equal to K, second form. P is proportional to D, third form. So whenever P is proportional to D here, so from proportionality relation, so what we can write, principle. So before that principle, now let me take what, definition. At constant temperature, the pressure of given mass of gas, at constant temperature, the pressure of given mass of gas is proportional to density, This is also called as what, Boyle's law. So now in the place of what, this one, if I want to write principle, so P1 by P2 is equal to what we can write? It is proportional relation. So where there is a 1, we will get what, again 1. Where there is 2, we will get again what, 2. So P1 by P2 is equal to D1 by D2. If inverse relation is there, where there is 1, we will get 2. Where there is 2, we will get 1. In proportional relation, where they will get, we have what, 1, though there we should get 1. If 2 is present, 2 we will get. So this is the what, third form of Boyle's law and principle. Now graphs I am taking. So first graph I want to draw what, P versus what, V. P versus V. I want to draw P versus V. What we have relation? P is inversely proportional to 1 by V. So P is inversely proportional to 1 by V. So this one I should take what on, y axis, and second one we should take on x axis. So when we plot, If pressure is more, volume is less. If pressure is less, volume is more. So that's why if pressure is more, volume is less. If the pressure is decreases, volume is increases. If pressure is decreases, volume is what will happen, increases. So which type of graph we got? So I got what? Rectangular hyperbola. Rectangular hyperbola. Rectangular hyperbola, and the name of the curve is what? Isotherm. Why it is called as isotherm? Because iso means same, therm means what? Temperature. So same temperature or constant temperature, hence it is called as what? Isotherm. Isotherm. We got what? This type of graph. Next one, second one, if I want to plot P versus 1 by V. P versus 1 by V. So when I what plotted P versus 1 by V, here what versus? P versus 1 by V. So that's why I should take what? P on what? Y axis, 1 by V on X axis. We have what? P is equal to K by V, or P is equal to what? K into 1 by V. This is present as what? Y is equal to mx form. So that's why how we will get a straight line we will get, which is what? Passing through the origin. Straight line we will get which is passing through the origin. So when we plot P versus 1 by V, we got straight line. Next graph, PV versus V. So I should take what? PV on y axis, V on x axis. PV versus V. What we have? PV. What we have? PV is equal to constant we have. So that's why y is equal to what? Constant. Y axis, y is equal to constant. Y is equal to constant. How it is present? Parallel to x axis. Parallel to x axis, such that I will get this type of graph. This type of graph. Next one, fourth type of graph, let we consider. So PV versus P. PV versus P. So that's why I should take what? PV here, P here. So now PV versus P. Here also what we have? Relation PV is equal to constant. So y is equal to constant. How I will get y is equal to constant is what? Parallel to what? X axis. Parallel to x axis. If I draw, so such which type of graph? V versus PV. Which type of graph I will get? So I should take what? V on what? Y axis, PV on what? X axis. So how we have what relation? PV is equal to constant. So PV is equal to constant. PV is what? On x axis. So x is equal to what? Constant. X is equal to constant. How it is present? Parallel to y axis. This type of graph. Also in examinations these type of graphs are what? Asked, but this type of graph is not asked. So that's why there is a probability to ask what? This type of graph. Next one, let I am taking what? Log V versus log P. Log V versus log P. First we develop what? A relation. So we have what? PV is equal to constant. Taking logarithm both sides, what I will get? Log PV is equal to what? Log K I will get. Log PV is equal to what we can write? Log AB is equal to log A plus what we can write? Log B is equal to what we can write what? Log K. Now what? Log V is what? Keep here and take to log P that side. So that's why log K minus log P. I am rewriting as log V is equal to minus log P plus minus log P plus log K. How it is there? Log V should be present on y axis, log P should be present on x axis. So y is equal to minus mx plus c form. How it will goes? Y is equal to minus mx plus c. So this is the what? Y axis. Y axis is what? Log V. This is what? X axis, and on x axis log P. So y is equal to minus mx. How it will present? Inverted graph. Inverted graph. So here what? See, this is the what? Intercept. This intercept is equal to what? Log K. Log K. So here what? Slope is equal to what? Minus 1. Slope is equal to minus 1. So this is the what? Relation among what? Log V versus log P graph. Now I am plotting P versus V. P versus V. So we are already discussed what rectangular hyperbola we will get. This is at what? T1 constant temperature. Now at T2 constant temperature I got this type of graph. At T3 constant temperature I got what? This type of graph. Then he is asked as write relation among what? T1, T2, T3. T1, T2, T3. How we can write? So in order to write what? In order to solve these type of problems, we should take what? Perpendicular from what? X axis. So in major problems we will take perpendicular from x-axis. From the intercepts you take what perpendiculars onto the y-axis. So y-axis. So you have what relation, what whenever what going upward, these p values are increases. So this is the what t1 graph p1, t2 graph you can take p2, t3 graph you can take what p3. What is the relation among p1, p2, p3? Upward increases. So that's why p1 is less than p2 is less than p3. So we have what we have t and p relation. T and p relation is what Geluzak law. So from Geluzak law what we have, p is proportional to t. That means what, how p's are there, in the same manner t's are present. T1 is less than t2 is less than t3. So this is the what relation in what these in this graph of t's. Next one, seventh one I am taking if I want p versus 1 by v, p versus 1 by v graph if I plotted, so I should get what, straight lines passing through the origin. So such type of graphs I should get. This is at what t1 temperature, this is at t2 temperature, this is at what t3 temperature. Write relation among what t1, t2, t3. In order to get relation, what is the trick? We should take what so perpendicular from where, x-axis. From the intercept you take what perpendicular onto the y-axis. So on y-axis upward values are increases, p1 not it, this is t3, so that's why p3, t2 p2, this is what p1. So that's why what p3 is less than, p2 is less than p1, upward increases. So what we have, p versus t relation, p is proportional to t according to Geluzak law. How p's are present, in the same manner what t's are present, because proportional relation. So t3 is less than, t2 is less than t1. So this is the what relation. So if we plot PV versus P, PV versus P, we got PV is equal to what constant we have. So that's why y is equal to constant, y is equal to constant parallel to x-axis we will get. Y is equal to constant parallel to x-axis. So now what if I want plotted at different temperatures? This is T1, this is T2, this is what T3. So different temperatures if we are plotted. So now, so how we will solve? In order to solve, what is the trick? We should take perpendicular from x-axis. From the intercepts you take what perpendicular onto the y-axis. This is the what T3 graph, so that's why P3 V3. This is the what T2 graph, P2 V2. This is the graph T2 graph, P1 V1. Here PV is there. So that's why what is the relation? So upward increases. So P3 V3 is less than P2 V2 is less than what, P1 V1. So now here what, pressure is constant pressure. We took what, constant pressure. So that's why P's are constants. So that's why V3 is less than, V2 is less than V1. What is the relation among V and T? According to Charles' law, V is proportional to T. So that's why whenever V is proportional to T, we can write what, where the same relation we can write in terms of T. So T3 is less than, T2 is less than T1. So this is the what relation among what these what measurable property, these what given what values. Next one, so if I plot P versus D, which type of graph I will get? P versus D. So pressure I should take on what, y-axis, density I should take on what, x-axis, P versus D. So we have what according to Boyle's law, P is proportional to D we have. So P is equal to, we can write what, K into D. So y is equal to what, m into x. Y is equal to mx. So that's why we should get what, a straight line passing through the origin. Straight line passing through the origin. So this is the what about the what P versus D graph. P versus D graph. Now here I will give you what one question. So solve it. So if I want draw P versus D graph, what I got, what straight line passing through the origin. So now what at different temperatures T1, T2, T3. So what is the relation what among T1, T2, T3? T1, T2, T3, T1, T2, T3. So you should get as what T1 is greater than, T2 is greater than, T3 you should get. Solve it. Next one, another graph I am taking. Another graph I am taking whenever what I plotted P versus 1 by V at a different number of moles. At a different number of moles, I got what straight lines so passing through the origin, passing through the origin. So what is the relation among these what n1, n2, n3? So in order to solve, what is the trick? We should take what perpendicular from what x-axis, and from the intercepts you can take perpendicular onto the y-axis. This is the n3 graph. So that's why P3. N2 graph, you can write P2. This is N1 graph, you can write P. So in up y-axis going upward, values are increases. So P3 is what less than P2 is less than P1. So now he is asked number of moles. What we have? P is proportional to N. P is proportional to N. How P's are there? In the same manner N's are present. So that's why N3 is less than N2 is less than N1. So this is the what relation among what these. Next, practical importance of Boyle's law. Practical importance of Boyle's law. So now let me discuss points wise. So Boyle's law is express an experimental fact that gases are compressible. So Boyle's law what give an what experimental fact that is the what gases are what compressible. When pressure is increases, volume is decreases. If pressure is increased, what will happen? It is this what piston going downward. So volume is decreases. Volume is decreases. That means what it can give an important experimental fact that is gases are compressible. Gases are compressible. Next one. So when gas is compressed, the same number of molecules because gas is not escaped out. Same number of molecules occupies smaller space. When what gas is compressed, same number of molecules occupies what? Smaller space. Smaller water space or smaller volume. Next one, third one, let me take gas is denser at high pressure. The density of the gas is more at high pressure. Why it is more? Because volume is decreases. So what volume is decreases? So D is equal to what? M by V. Mass is same. D is inversely proportional to V. So that's why when volume is decreases, density is what will happen? Increases. So when gas water is more dense or high dense at where? At high pressure. At high dense at what? High pressure. Next one. Air at what sea level is denser because compressed by the mass of air above it. So air at sea level, air at what? Sea level is what? More dense. Because what will happen? More dense because there what more water air is present above the water a particular air. So that's why it has what? More density. Next one, fifth one. However, density and pressure decreases with an increase in altitude. So that means what? Whenever the what altitude is increases means when we are going upward from the what sea level, what will happen? Density and pressure both are decreases. Why it is what decreases pressure? Because the force applied upon what unit area is decreases. Here what? More air is present, so that's why here pressure is more. If you go to here, so this air is what not present upon this one, so that's why somewhat less pressure. When we are going upward, pressure is what will happen? Decreases. So that means what? If the what atmospheric pressure on the earth is if 1 atmosphere, so upon the what Everest, Everest hill, that will what will happen? The pressure is what? About what? 0.5 atmospheres only. 0.5 atmospheres only. So that means what? Whenever what mountain climbers are present, what will happen? If they are going in the upward, what will happen? Pressure is decreases at high altitude. So that's why that will causes slugging feeling or sluggish feeling. So and as well as what? They got what? Some headache. Next one, so that means what? These are the what feelings due to what? Less oxygen intake. So this is the what? Sluggish and as well as what? Headache, like what diseases they will fall down. Next one, inside the inside of jet aeroplanes specially maintained at normal pressure. So that means what? In what flights, jet aeroplanes, they will what? Flies more than 10,000 kilometers above, more than 10,000 kilometers height from the sea level. So that's why at that height extremely low pressures are present. So that's why special designing is required. Special designing is what required. So this is the what about the concept related to what Boyle's law and practical importance of Boyle's law. Now let me I will pause the video and you can take screenshots. From those screenshots you can write what? Notes.